pretty much just review. Systems of equations. A system of equations is any collection of two or more equations, which means you're solving for two or more variables. In this lesson, we're just going to have two variables. Now, a solution set of a system of equations is a set of all values that satisfy all equations. In algebra, you use three main methods to solve systems of equations. You use graphing. It's not a great way to do it. But then we learned elimination and substitution. Graphing isn't the best way, but we're going to start off that way because graphing only works if you're really good at drawing straight lines and you have a really good XY plane and the answer is a whole number and not a decimal. That's a lot of what ifs. So if it's up to you, if I say choose whatever method you want to solve this, probably don't choose graphing. But we're going to start with graphing because we got stuff. Now, when graphing, we're going to simplify each equation and see where the graphs intersect. If the graphs do not intersect, there is no solution. And we'll talk about that on the other side. If the graphs happen to overlap, in other words, you draw a line and you draw that same line over it, that is going to be all solutions will work. So let's just take a second and go to not this one. I got the wrong one up. That one already has like answers going on. Go to that one. All right, you should have both of these lines. I think on yours, this one's pretty light. So just make sure to cover it up. I'm going to point out this one specifically because I usually put one of these on the test where I actually give you the graphs. And I say, what's the solution? I might not even give you the equations. I might just give you these graphs and say, what's the solution to this system? Now, what I want you to remember from algebra is lines aren't arbitrary things with slope and distance or something. These lines each represent all of the solutions to a particular equation. So if I have y equals 3 over 2x plus 3, and I see this line right here, every point on this line is a solution to this. So this line in itself is a solution set to this equation. This horizontal line right here is the solution set to y equals -3. Any point on here will satisfy this equation. Now, we're not going to give you a system of equations. That means I give you two systems. I got two equations, and I need to solve it. I need to figure out where do both systems overlap. Where do the solution sets overlap? Well, they overlap at just one key place, and that is that point right here. So when I'm asking for the solution set, if I give you two lines and I ask you for the solution of that system, you're going to look for where do they overlap. It overlaps right there. This is your solution. They both share that point in common. Now, if I ask you to solve the system, I don't want you to just point to it and say, this is my solution. I want you to actually give me what that point is. So there's two ways to give our solution on this one, and that is to actually give me a point. So that would be what it 1, 2, 3, 4. That would be -4, -3. Or you can give me it like this. X equals -4, y equals -3. Either answer works. You're going to see I usually typically lean towards this one because this is kind of how you answer when using solution sets for elimination and substitution. What's your x value? What's your y value? Rather than having to read a point. So I lean towards this one, but this is a 100% fine answer. All right, so if given two graphs, we just find out where they overlap. And just a reminder, if it's the exact same line, it's all solutions. If it's a parallel line, they never intersect, so there'd be no solutions. They don't overlap, it has no solutions. All right, let's go to this one. This one we have to actually graph on our own. Now, before we graph it, I do want to go over just a quick rehash of slope-intercept form. Slope-intercept form is that y equals mx plus b. I'm just going to write it down here. You can probably fit it all up here too. I just don't have it up there. Where m is our slope and b is our y-intercept. That's why we call it slope-intercept form. It's got a slope and it's got an intercept on it. It's crazy how they name it like that. Let's bless you. Let's talk about bless you. Let's talk about slope real quick. When I say the word slope, a horrible way to phrase it, but what comes to mind when I say slope? I'm looking for a specific thing, but it's a horrible way to lead it. What do you think of when I say slope? Rise over run. That's what I was looking for. It's rise over run. Rise over run. Another way to look at that is it's called delta y over delta x. Delta in math and physics usually stands for change. Change in your y value over change in your x value. We won't need that today, but a lot of times when you're going back to slope, change in y and change in x makes more sense than rise over run. Change in y is your up or down. Change in x is your left or right. That is rise over run. Change in y and over change in x is the same thing as rise over run. All right, so our first one's already in slope-intercept form. We have y equals 2x minus 2. Our slope is 2. When I deal with slope, I usually change it to a fraction. Either I actually write out the fraction, it's 2 over 1, or I just in my head picture it as being 2 over 1, because I do need that rise over run. And this negative 2, note it's not 2, it is negative 2. That is your y-intercept. So when graphing in slope-intercept form, the first place you're going to start is your y-intercept. My y-intercept is negative 2, so we find the y-axis, and we find negative 2, and we put a point on there. So at negative 2, we put a point on there. Then we rise 2 over 1. Up 2, right 1. Up 2, right 1. So I'm going to go up 2, right 1, and I'm going to go ahead and put a point there. All right, if you want to, you can put more points on there to give it more accurate. You really only need 2 points to draw a straight line as long as you got a nice ruler on there. So I'm going to go ahead and I'm going to connect those 2 points. And that line right there is my y equals, what is that? 2x minus 2. Really, there's 2 ways to this. We're not going to go through both ways. We should know how to graph lines. One way is to plug a 0 in for x and find our x-intercept or y-intercept. We can plug a 0 in for y, and we can find our x-intercept. Instead, I'm going to go ahead and I'm going to solve and put it into slope-intercept form. So that means solve for y. So that means I'm going to slowly manipulate it as 2y equals negative x plus 6. I'm going to divide everything by 2. Which is going to equal negative x divided by 2 plus 3. I'm going to rewrite this just a little bit. I'm going to rewrite it instead of negative x over 2, I'm going to write it as negative 1 over 2 times x plus 3. So we can see our slope a little easier. And we can see our y-intercept. Y-intercept should be easy. We just go up 3. Up 3 on our y-axis. And we put our point here. Now, I want to talk about the slope right now. When I deal with negative slopes, when you have a negative fraction, you can either put the negative in the numerator, you can put it out front, or you can put it in the denominator. For me, I'm always going to put it in the numerator, because then I'll know it's either going up or down. If I put negative 1 up here, it tells me go down 1 and right 2. So look at what's positive to know what direction to go. So a negative 1 makes you go down. So we're going to go down 1, and we're going to go right 2. Down 1, right 2. And we're actually going to see where those 2 lines overlap. I do want to point out there are times where, when you're plotting slope and all of a sudden you're off your graph, you can go the opposite direction. So if it's down 1 over 2, I could also go up 1, left 2. So you can always go the opposite direction. For some reason, you go off of the graph. Like you end up way up here. Rather than doing that, I would go in the opposite direction. So you can always go the opposite direction with slope. Connect those lines. And we look at where do they overlap? Well, they overlap at this point right here. That is our solution. So the answer to this one is either going to be 2, 2, or we're just going to put x equals 2, comma y equals 2. However you want to answer that. I do want to specify, don't just point to it and say it's solution. Someone did that on a test last year, and I felt bad, but I had to take off points. We can't just point at the solution. We have to actually put the solution answer down. It's nice that you know where the solution is, but you do have to use that to give me your answer. All right, so that's graphing. Don't graph unless I tell you to graph. If you want to graph other ones, awesome. Just take your time, and my advice is don't. If I give you the option, use elimination or substitution. I'm a fan of elimination. Anytime I'm given a choice, a lot of times I'll just use elimination. That's just my preference. If you like using substitution more, if I give you the option, use substitution. But I gear towards elimination. Elimination is based upon the fact that you have a zero pair. A zero pair is often called an opposite pair. If I give you 50x, the opposite pair will be negative 50x. Your zero pair, when added, should equal 0. That's why it's called the zero pair. So when I'm told to use elimination, the first thing I'm going to look at is there a zero pair? Yeah. If you already have a zero pair when you line stuff up, you don't have to do any manipulation with these. So once again, what I'm looking for is, do I have a zero pair? I do have a zero pair. It's right here. That's my zero pair. As soon as I have a zero pair, what I do is I put a little bar underneath it, and I add them. I'm adding my two equations together. We're allowed to do that because these equations are balanced. So as long as I line everything up, I can add everything. That means I have 3x plus 2x equals 5x. Negative y plus y equals 0. If you did not get 0 there, you made a mistake. 9 plus 1 is 10. That means really all I have is 5x equals 10. Divide both sides by 5, and you should come up with x equals dos, or 2. 2. How do I find my y value? Libby.
Plug it into
any of the other two equations, right? Probably don't want to plug it into this one because that would be 0, but we're going to plug into either one of those. Pick the easiest one. There really isn't an easiest one here, so I'm just going to go ahead. I'm going to pick out the 2x plus y equals 1. Like Labib said, you can pick either one of them. You come up with the exact same answer. So we have 2 times 2, which is 4, plus y equals 1. Subtract 4 on both sides. We should come up with y equals negative 3. I do not require that you rewrite this. I have x equals 2. I got y equals negative 3. It's clear today what your answer is to me. If you want to rewrite it, if that's what you like better, rewrite it. I'm okay with just x equals 2, y equals negative 3. Now, do as I say, not as I do, I guess, up here. I would check my answers, particularly on a test that doesn't have test corrections. Don't lose that point because you didn't check your answers. In this test particular, if you did not check your answers, I will probably take a full point off, even on an easy mistake when I normally would take out half a point. Because checking your answers is pretty easy to do on these. In fact, I could do this in my head. I can go, okay, 3 times 2 is 6, minus a negative 3, so it's plus 3. 6 plus 3 is 9. 2 times 2 is 4, plus negative 3 is 1. Yeah, everything works out. I would at the very least just mentally check to see if those numbers make sense in those equations. All right. This one, if I just went ahead and added, don't do this, but if I went ahead and just added, I would have 5x minus 5y equals 10. I just created a new equation. Didn't help me solve it because I don't have a zero pair. When you add them, you must get rid of the x or you must get rid of the y. So that means I cannot just start using elimination. I need to have a zero pair. How do I create a zero pair? Yeah, Jacob.
You can multiply the top by like 3 and the bottom 1 by 2.
So we can go 3 over 2. I have one adjustment to that. So if I multiply this by 3, multiply this by 2, I assume we're trying to get rid of the x's, right?
Yeah.
Will we have a zero pair? It'll be close. Of 6x.
-2.
Yeah, -2 or a -3. So just make sure when you do your multiplication, one of them turns out to be negative and one of them is positive. So I'm going to throw a negative onto the bottom one. Biggest mistake I see with elimination. Make sure you distribute to everything. I see this Algebra 1, Algebra 2, Geometry, Pre-Calculus. You forget to distribute that 3 to the constant. That's the biggest mistake I see. Make sure that 3 makes it all the way to that -2. So that 3 has to make it to everything, which is then going to give us 6x. We got -9y is equaling 3 times -2, which would be a -6. Make sure that -2 goes to everything. -2 times 3 is a -6x. -2 times -2 is a positive 4y. And a -2 times 12 is going to be a -24. 6x minus 6x. That's perfect. That's a zero pair. Those just cancel out. Then we have -9y plus 4y, which would be a -5y. Minus 30. Divide both sides by a negative. Becomes a positive. It becomes a positive 6. You can now take that y and plug it into any one of these y's. Doesn't matter which one. I'd probably pick one of the original ones because they're usually smaller. They weren't manipulated. I didn't multiply by something. So let's go ahead and I'm going to take the second one. So I'm going to use the 3x minus 2y equals 12. I'm going to take that 6. I'm going to plug that in there. And so we're going to have 3x minus 2 times 6 is 12. Equals 12. Add 12 to both sides. We'll have 3x equals, looks like 24. So we're going to have x equals 8. Any questions on elimination? That is the last time I'm going to show you elimination. So make sure if you have questions, you ask. Okay, then the last big thing we're going to learn today is substitution. Substitution works just as nicely as elimination. My only concern with substitution is it makes you solve for a variable. It makes you solve for a variable. Thank you. So you need to either solve for a y or an x in either equation. Doesn't matter which one. I'm always going to pick the loneliest variable. So I'm looking at this y. It's pretty lonely. It just has a -1 out front. So that's what I'm going to pick for because it's the easiest to solve for. So I'm saying let's solve for this y. You could solve for this x. You could solve for that x. You could solve for that y. It doesn't matter. You just got to solve for a variable. I'm going to go ahead and solve for this y right here. So let's kick that out. And let's go ahead and start solving for it. So we have 3x minus y equals 6. I would subtract 3x from both sides to give me -y equals a -3x plus 6. Divide both sides by a -1, which just changes all of the signs. So I have 3x minus 6. Really, your only big concern when you're using substitution is make sure you substitute it into the right equation. You cannot plug this back into the equation you used. You have to plug it into the next equation. So we're going to take that 3x minus 6 and we're going to plug it in for that y on the other equation. So we're taking that 3x minus 6 and we're plugging in for the other equation's y. And that's going to leave us with, I didn't give myself much room here. Let's go 6x plus 5. Make sure to use parentheses because that 5 needs to be distributed to the 3x and the 6. So do not forget your parentheses. That's going to give me what? 6x plus 5 times 3x is 15x. 5 times 6 is -30 equals -23. 6x plus 15x is 21x. Add 30 to both sides. We'll have a positive 7 on this side. We're going to end up with x equals 7 over 21, which reduces down to 1 over 3. So if I have x equals 1 over 3, I can either plug that 1 over 3 in here, I could plug that in here, or the smartest way with substitution, plug it into the y equals. You already have it solved for y equals. So all you'd have to do is plug that 1/3 in there and solve that right-hand side. Once again, it doesn't matter which one you plug it in. This just makes it a little easier. So we're going to have y equals 3 times 1/3 minus 6. Y is going to equal 1 minus 6. Y is going to equal -5. That right there is substitution. All right, we got a few more notes to take, but before we get to the notes, let's look at page 3 on our homework. If we look right above 5 and 6, 5 and 6 says solve each system by substitution. So we need to use substitution on those. But then it says determine whether each system is independent, inconsistent, or dependent. So all of your problems are going to have an answer, and then after it, it's going to say independent, inconsistent, or it's going to say dependent. You must have one of those words in each of those boxes. So let's go through these, knowing that we do need to keep track of which one's true and why. All right, so the 3 big words we're looking for is independent, dependent, and inconsistent. But let's start with consistent. If I say a system is consistent, that means it has at least one solution. At least one solution. Well, consistent branches off into 2 other categories. Independent is when that system has exactly one solution. So independent means you have exactly one solution. Those are the examples we did in class. When graphing, you're going to see intersecting lines, just like we saw in the first 2 examples we did in class. When you're using elimination or substitution, you're going to end up with x equals a number and y equals a number. Then you'll know that you have independent. So graphing, you just see 2 lines intersect. For elimination or substitution, you have an actual answer. For dependent, dependent means there's infinitely many solutions. On a graph, those will be 2 lines on top of each other. Where do they intersect? Everywhere. It's all solutions. It is a dependent system. If you're using elimination or substitution, you will not get down to x equals and y equals. In fact, all of your variables will disappear. Your x's and y's will cancel out, and you'll end up with some kind of true statement. A lot of times it's 0 equals 0. So if it says 0 equals 0, 3 equals 3, 4 equals 4, it is a dependent, infinitely many solutions. So we have independent, one solution, dependent, all solutions, inconsistent, no solutions. It's going to be no solutions if when graphing you have parallel lines. Where do they intersect? Never. There's no solution. When you are solving using elimination or substitution, you're going to end up with a false statement. You'll come up with something like 5 equals 9. If it comes up to a false statement, it means it's inconsistent. These are those 3 that you need to know. Once again, independent if you see intersecting lines. Overlapping lines is dependent, parallel, inconsistent. If you get an answer, independent. If you get no variables, it's either true or if it's false. True, dependent, false, inconsistent. All right, the only last thing we need to do is, there is a word problem on your homework. There is a word problem on your test. The word problems themselves are not supposed to be super tricky. You got kind of a nice one on your homework. This one is the ultimate easy word problem for systems. It starts off with some people on stakeout protecting the earth from the scum of the universe. Agent Mulder observed 5 black men enter a coffee shop and get 3 donuts and 5 coffees for $3.30. Next, 3 aliens in disguise entered the shop and got 4 donuts and 3 coffees for $2.75. How much does it cost for a coffee and how much does it cost for a donut? Now remember, with word problems, almost all of it is useless information. I don't care if there's aliens. I don't care if there's Mulder. What I really care about is this statement right here. The donuts and the coffee costing a certain amount of money. So this says 3 donuts and 5 coffees equal $3.30. And right below it, it says, you know what, 4 donuts and 3 coffees cost $2.75. Well, those are 2 equations. Those are 2 equations, and in order to set them up, I need variables. So I'm going to get super creative, and I'm going to say donut. I'm going to use a D for that one. And for coffee, you'll never guess, but I'm going to use a C for it. Feel free to use X and Y. So a lot of times I'll use X and Y. It's just some people like to have those little C's and D's so they don't have to go back and figure out what their X and Y's were. All right, so we have the first circled one says 3 donuts and 5 coffees equals 330. So that means, hey, if I have 3 donuts and I multiply it by its cost, let's call it D, plus 5 times the cost of coffee, that's going to equal $3.30. Just like 4 donuts plus 3 coffees is going to equal $2.75. Choose any method you wish. I want you to go ahead and solve these. Don't graph it. Don't graph it. It's going to be really hard with decimals. So let's use substitution or elimination, your choice.